Hello everyone, this is Dave Brambert, President of Fifth Wave Manufacturing. We're here today in Hoffman Estates, Illinois at the location of one of the smart factories from TRUMPF. And with us today, Andreas Bunz, who is multiple duty, right?
That's correct.
You take care of the 7030 and I think probably any high-end laser, right? And also robotics. And we have a chance to talk about robotics.
Absolutely.
So I thought we would do that. Thank you for having me here today.
Of course. Great to have you here, Dave.
Yeah.
As you said, I'm Head of Robotics is my role at TRUMPF here in Hoffman Estates, just outside Chicago. And the product manager of the TruLaser Center 7030 is sort of the second role. And I'm doing that sort of in conjunction right now.
Yeah. And robotics, it really is all over the place within TRUMPF. So is AI. And I'm sure both of those areas kind of intersect for you. If my kids are all grown and in their careers, but if they were a little bit younger, I might say you should check out robots or you should check out AI. But particularly robots, a lot of AI's function and a lot of vision function comes from robotic work.
Yeah, that's right.
So talk about what TRUMPF is doing, where some of the biggest impact is from robotics.
So TRUMPF is offering off-the-shelf solutions for sheet metal fabrication, right? Lasers, press brakes, welding machines. The TruLaser Center also is one of the, if not the most advanced laser cutting and sorting machine. However, not every challenge, not every goal that our customers have can be addressed with our off-the-shelf products.
Yeah.
So the idea was, let's do complementary to our standard portfolio custom robotic solutions that go well together with our products. And first and foremost comes to mind bending, for example. Parts might be too large or they might be too heavy for our regular automated press brake portfolio, which we also see behind us here in a smart factory. And secondly, then the sorting operation. The sorting of laser cut parts is a challenge that until 12 years ago, nobody had solved. That's why TRUMPF successfully developed and established the TruLaser Center that cuts and sorts autonomously like no other machine.
Yes.
Now, on the robotics side, it opens up more possibilities if we cut the parts on a very fast and efficient laser machine and then present it to a robot that, for example, as a Sortmaster Vision, does not even need further programming, but detects the part and can sort them and stack them also autonomously. So it really goes well together with our established portfolio. And that's on the Sortmaster Vision side also where AI plays a big role to simplify, or in this case, even to eliminate programming needs.
Yeah, I was thinking a part could even be too small to really be safely handled by human hands, and here comes a robot for that too.
Too small, or we have thin parts, right? They might be so sharp that regularly employees get hurt, or it's a tiring operation if you only have to do 2 bends and it needs a couple of thousand parts a month. So there's a lot of aspects why robots make sense to go with our products.
Yeah, and the systems around that seems like accommodate the robot very well, because many of their, even a tooling rack, every tool in that rack, whether it's a punch or a die, has an RFID tag or some other kind of identifier so that you know where that is at any time.
Yeah. So, for example, if we talk about robotic solutions for press brakes, of course we have the TruBend Cell 7000 and the 5000 that also do tool changes. So on a custom solution, we also want to incorporate the tool change to allow as much autonomy, as we say, as is possible. However, if a customer has a goal, we want to do very flexible manufacturing from medium size to very large parts, then we look into that, and maybe the quantity for this project is not so high, but we still find and qualify, and then build a custom solution for that customer, which maybe otherwise would have not gone with the TRUMPF portfolio.
Interesting. I didn't think of the custom aspect of that. You know, it seems like as we watch the whole industry develop over time, much was devoted to our laser goes faster than your laser, or our bending, you know, our movement, our speed of the press brake until we hit that short approach speed is so fast you'll never beat it.
Yeah.
But we shifted from that and said, okay, we can make all these things go faster. The real time savings now is in between steps.
Absolutely.
Right? And doing the things that humans do or humans don't do.
Yeah. So I think there's a natural, like the laser power is increasing naturally, then the cutting speed increases.
Yeah.
But everyone is realizing and more realizing that it's not about the cutting time as such, right? Mm-hmm. People look for a lot of green lights on the laser or on the cutting machine.
Right.
But what happens after that? Where does the part need to go? How does it get there? Is it ready for the next step? Do I have to handle it? Maybe I have to break it out, have to sort it, stack it, count it, forward it. So we could talk about robotics or AGVs in logistics, of course. How can they be integrated, and what happens when they arrive on the final destination, which could be a press brake, and suddenly we can connect them very flexibly, right?
Yes.
And
yes.
The indirect processes, right? Studies have shown that 80% of time is not value added at the moment, and
yes.
that we address not only with robotics but also with intralogistic solutions, of course.
Yeah, and lasers have, you know, if they were living beings out there on the floor, lasers have a pretty good life because they start off everything.
Yeah.
And if they mess up, the cost of a mistake isn't anywhere near what it would be post-welding, for example.
Absolutely.
You know, so you can always get back to, okay, let's feed another sheet on there. But having said that, that takes time too. And a lot of the robotic and even automation, non-robot automation within, say, a laser cutter, is aimed at first pass is just as good a pass as the 10th pass.
Yeah.
Same with press brakes. First bend is a usable bend.
First piece, good piece.
Yep,
Yeah,
yep.
absolutely. And exactly like you said, further down in the production chain, it only gets more expensive if mistakes are discovered later. And it must not even be a real mistake. It can just be one part missing, and the weldment cannot be finished.
Well, that's it. Yeah.
And so I talked about like sorting and then bending. All of that can be, you know, helped or solved with robotic solutions added by maybe vision and maybe AI. So I think there's a lot ahead of us. And of course, then we approach welding. And I mean, robots are big in welding since quite a while. Industrial robots or cobots.
Actually, yeah.
But how do the parts get there? How do they get into the fixture? Do we always need a perfect fixture? Is it multiple robots handling parts? I mean, there's so much out there, and we didn't even leave the production shop floor. We can talk about kitting, for example, multiple parts from different primary operations joined together. And so it's a very vast, it's a very broad portfolio. Actually a real project we work on at the moment is how do the sheets that, for example, need to be fed to our Stopa system, how do they get loaded?
Yes.
So there's ideas and there's concepts to load them with robots on the Stopa cards, and that also eliminates error. It makes sure that every stack is perfectly square, that it's in the right location, it's the right count, it's the right material, and that a laser center in this case can produce uninterruptedly because nobody accidentally booked the wrong material code to that pallet.
Oh, right. Okay.
So we think about, or we look at the whole value chain,
Yeah.
and see where we have a need, where we see a need, or where our customers tell us that there is a need, to say, please, TRUMPF, can you think about something? You know, even if not immediately, but we want to get better there. Yeah.
I mean, you're a large enough company where, as people look at their own business and fabricating and say, well, we have metal coming in one door and we have parts going out the other door, or products going out the other door. And you're a large enough company where you could just about outfit anything they would need, right?
Yeah,
within those
I mean,
walls.
we don't do paint lines, for example, right?
Well, yeah, okay.
But things like that, we have customers that still integrated that into our software ecosystem, for example.
Yes. Well,
And then
actually,
connectivity and transparency is a big piece to make that work and have a high OEE in the end. Yeah.
yeah. No, I saw that in Farmington. I went to the opening there.
Our own brand new smart
Yes.
factory in Farmington does that to perfection, probably. Yeah.
Yes, that what a building that was. But now, you know, will there be a rivalry between Hoffman?
So I'm pretty happy that you came here, right? Otherwise we would have met in our smart factory there. But
That's right.
yeah, Hoffman Estates is the original smart factory.
Yeah, I remember when this opened. Mid 2010s, something like that.
Mid 2017, yeah.
Yeah.
So we're actually, in our 8th year of operation, and
Yeah.
as you also saw while we were walking the shop floor, there are some changes happening. So
Definitely.
we constantly update our own machine equipment with the latest tech, and with FabTech around the corner, preparations are in full swing for that.
Sure. Yeah.
And also thinking about robotics on the shop floor.
Yeah.
I believe at the moment we have in total like 7 different robots integrated or as part of our machines.
Yeah.
And that number will only go up. Yeah.
You know, I go into many shops, as I'm sure you do, and I ask people, where's your bottleneck? And more than half the time they say welding or joining or whatever the case is. What if somebody invented a fixturing robot? I mean,
Yeah, I mean, we can invert the principle of the TruLaser Center, right? With the many pins that lift our
Yes.
parts. Why not have them come into shape and the part just sits on it and it adapts based on 3D geometry? I mean, probably I want to have Robin next to me to answer that question.
Oh,
because
okay.
I would only dream about it.
Yeah.
But he's probably more close. But I mean, technically I can see that happen. If you have a set geometry family of parts.
Yeah.
I mean, it's only a function of complexity to make that happen, I think, right?
Yeah, I would think that's where the most time might be gained. Now, you guys are famous for having data, for studying things. Do your studies and does your data help you say, we need to concentrate on this area of robotics right this minute? Because, I mean, does all that data help you do that?
I think so yes, TRUMPF collects or has data available for that. I would phrase it in a way to say it doesn't spark the field of activity where we look into robotics, but once we have ideas, once we hear requests, then we try to double check, get a solid data foundation underneath that supports that assumption that it makes sense, for example, to automate intralogistic workflow of a certain process within our fabrication environment, or a certain bending process can be maybe better with a custom robot solution relative to our current portfolio. Okay. Not saying that the current one is not good. Right. TRUMPF makes very flexible equipment, but if somebody has a very specific requirement, there might be a more efficient solution, and more efficient could be shorter cycle time, or it could be more space efficient, or it could be higher autonomy, so they can produce lights out in the night. And then we would look into the data, like which parts are they producing, and try to support our studies with that data.
Okay. Tell me, just in the welding piece of business here, you're employing both a cobot in the form of the UR thing in the 1000, and then in the larger 5000, there's a KUKA, that's the basis of that. And is the line about a robot being a little more precise. Is that the case? Are you finding that the case, or not? I'm not disparaging any brands or anything, but
Yeah, I think across all brands, right? Cobot have the integrated safety, which an industrial robot has not. So an industrial robot also has to have some surrounding equipment to help with the safety aspect in our environment. I think that's the biggest difference. Okay. Technically, like speaking on the arc weld, I mean. On the operational side, you can teach the robot or the cobot, so in this case, very simple. With an industrial robot, that is not so simple. But on the welding result, I believe that would not make a big difference.
Okay.
Now, on the bending side, it's a different story, right? We want to be able to program robots offline to have, like we said earlier, first part, good part, also on a fully automated bending operations, because only then you can bring in new parts online fast and still run it in a flexible way. And if you do offline programming, then it doesn't matter. Is it a cobot? Is it a robot? A robot always will move faster because it has no integrated. It doesn't need to account for the integrated safety. Right? There's fencing around, there's other peripheral components around that take care of that. So industrial robot will always be better in terms of time efficiency during a production run. As long as you don't need the human interaction, right?
Yes, and in that case, but for doing, the coupon demo of that it's not complicated. It's something where somebody can say, okay, start here and there, and then
exactly right. And we have in the arc weld, we have the two-station operation. So the operator can be very close to the other station while it's actually working on that. And with the industrial robot, that setup would certainly look different. But for example, and we didn't pass it on the shop floor, but in our flex cell, in the small, the high-speed automated bend cell, or bending cell, we have an industrial robot from Fanuc integrated that is very versatile and very fast in feeding those little parts in a high quantity to the 7050 electric press brake. So we're looking to have the right solution, the right robotic solution for the right application. And as we go larger, and maybe we can take a walk later again, in the back corner you see a 165 kilogram robot automating our panel bender.
Wow.
And fully for loading, for unloading, and stacking the parts, and overturns, everything that is needed. So that would certainly not be the right application for a cobot, for example, right?
We talked a little bit about this just walking into this room, but tell me how much activity. I know that TRUMPF just made an investment in an AI company that I think is a German company, if I'm thinking that right.
Okay.
Just a few days ago, I think, or a week ago. How much of imaging, like machine vision, or AI, I guess take those as separate questions, come into your area, because they're a natural bolt-on with robotics.
Vision is playing a big role, especially in like locating parts, in orientation, in again making sure it's the right part in the right spot. Be it directly bolted onto the robot, or offline, or not offline, or disconnected, like on stationary cameras, like we have on our Saltmaster Vision solution, that basically looks down, analyzes the cut nest, the parts that lay around, and then processes and does approach and path planning for the robot, including the gripper, like fully automatically. That would not be doable without vision.
True.
Because in a classic setup, you have an interface, you get the part information, you get the nest layout, and everything is transferred to like a processing routine that then identifies, okay, this part first from this angle, in this way we retract it, and then the second, and then this third. AI,
is that touching your area for robotics?
AI plays a big role. I mean, I don't want to say it's a hype. It's surely not a hype. It's here to stay. I mean, we're like fast on the way to super intelligence, probably faster than we all really want, and few of us really understand what that means. But it does revolutionize also the way how we can, as TRUMPF, approach challenges, right? Not always is the solution that we see in a classic development setting is not always the best solution. And with AI tools helping, especially in things like coding, especially in things like vision processing and predicting also, right? We talked about data, and like the data that we know can be fed into certain models to make
it can learn,
right? It can learn. The laser center extracts more than 40 parameters on every single part it removes with the Swordmaster speed. Now somebody might ask, what do you do with that data? At the moment we monitor and we check statuses and we sort of try and predict when a certain change like suction cups might fail. But this will only get better once we couple that with AI and real prediction models and learning models, right? And, I mean, TRUMPF has gone that path now since quite a bit, and in recent months accelerated also and put more emphasis on it as a focus for the company, not only in R&D but for the global strategy.
I'm sure there were some smart people who said, who could see, here's the main use of all this data to improve everything through AI to provide to customers. So they were doing themselves good by allowing that data capture to happen.
And that is a dialogue that obviously has to happen. Not every customer wants to share all the data, which is totally fine, right? We want to have a dialogue, we want to be transparent what we would do with it and what a customer could benefit. And it might not be an individual benefit, but the more that participate, the higher the overall benefit will be, right? Because it can be incorporated in future software versions, in updates, in bug fixes. We might get more faster, we might get more tailored to what actually happens in the field. And I think that's a like, for me, it's mostly about processing of data at the moment. We are, like, our development cycles are relatively, sophisticated, relatively long. We don't put out a new fully automated laser machine every 5 years.
Right.
And that is a difference relative to in the past. Laser power scaling is relatively simple. Everyone can do it more or less successfully. But if it comes to bending, if it comes to welding, the new generation will be developed, or we want to develop it in a way that is also here to stay, and that it can then benefit from all those technologies that are parallel emerging, like AI.
This is an industry-wide thing, and you mentioned you can't do a new 70-30 every year. Here's a 70-31, or and yet for other products, you can just feel it. You can sense that the cadence is increasing. And it used to be, what are we showing at FabTech every 2 years, and now it's every year easily with multiple products. And it's even kind of starting to go to like 10 months and 8 months. Will robots help you guys with that?
So I'm personally convinced robots will help us. Not only because we just created the Custom Robotic Solutions division at TRUMPF, right, which I'm heading, so I have to be convinced, right? And I'm excited for that. And FabTech this year will be a first and a very big milestone for us. But the adaptability of our existing solutions to ever-evolving requests or challenges or just ideas that our customers have, right? We might bring up different series of press brakes, for example, 1,000, 3,000, 5,000, 8,000, right? And like you said, not every series gets an update every year.
Right.
But we're carefully managing our portfolio on like where we roll out which updates, which features, where does it make sense, where do we introduce it, and then sort of carve that to fit our current market situation, I think also, right? And this in the future is very exciting because let's take a Stopa system, for example. very large, the spine of all of our smart factory. It's the central piece of material logistics in terms of from raw material to cut and to bend part at the moment.
Yeah.
Somebody puts that in, that stays for 15, 20, 25 years. But our machines around, they evolve, they get changed, they need to adapt to the changing environment. And I think there is a gap at the moment, certainly, that we can close with robotics, with AI, with processing of relevant data, and deliver better solutions for our customers.
I think that's right. And I think, AI is very related to software also. And you can have the same machine do different things according to what software you put in it, even with only the tooling that it came with.
Yeah,
right?
I mean, change a certain set of tools and suddenly you bend different parts with a different radius. And we're able to program that fully offline, simulate it, be sure that the first part is a good part, and predict the results, right? And then even during the bending process with our integrated ACB laser angle measurement, right? We feed that back to the robot, we correct the bend, so making sure the quality is there. And that's what customers expect from us also, I think, rightfully so.
Let's say it's 2030. Look around you, you'll still be working. I may not be working, I might be retired, but I'll probably still be working. Look around you in the landscape of fabricating, and what do you see that's different, that's very different?
What do I see? I believe that the shop floor in the future will be more clean than it is today. Clean in terms of there's not so much waste lying around, there's not so much material being handled like manually. Transparency and knowing where which piece, where which order is, where which machine and which production job has which status will play a big role, because we need that to be able to automate the whole floor.
Yeah.
And it will get more automated. I mean, we see it in logistics. Compare current logistics companies, left alone the big ones like Amazon and like the end-to-end solution providers. But compare them to 10 years ago or 15 years ago. Like it's exponentially the use of robots, mobile logistics solutions, and so on. And in a fabrication environment, it's more challenging, because not every job is the same, not every material that we get delivered is the same. You see it here when we do production. Sometimes the quality, the batch that we get is not what we expect, and then you have to adapt to it. So to find solutions that are able to do that will revolutionize the shop floor, in my opinion. And then having those machines that do best what they can do best, for example, cutting, bending, welding, integrated in a flexible way, that the operator as such will probably more become a logistics manager on the shop floor, or logistics, employee on the shop floor, making sure the individual technologies are happy, but then the automation solutions, they will, do the actual, do the heavy lifting, right? I mean, we already know, and the Midwest is a prime example. Good welders are insanely hard to get. Hardly, like so many people don't like to hammer out parts of a 1-inch plate for like 10 hours a day anymore, and rightfully so, right? There's better solutions out there. And I think this will just continue and increase in momentum. And I'm very happy to be part of that journey.
Well, all I can say is I really appreciate your opinions, because I know how they're driven. You've been in this business a while. I appreciate your time today for accommodating me.
Very welcome, absolutely.
We'll continue to do it as time moves on.
That sounds very good.
All right, thank you so much.
Thank you, Dave.